Okay, for our Tech 10 tonight, it's going to be Bob Naylor, WE6C, and he's going to be giving a talk on Smith charts. It's the first of 2 presentations. He's going to give the second part next month. Bob?
Thank you. Thank you. Wake the computer up here again. All right, Smith chart. Most of you are familiar with it. Does everybody have a copy of one that I left over there by Bruce? If you don't have one, you want one, make sure you get one. Anyway, it's for feed line, wavelengths, SWR, impedance, that kind of thing. So one thing everybody should remember to always do when you put up an antenna, measure your feed line. Measure it physically, 75 feet, 60 feet, 150 feet, whatever. Write it down, keep the figure somewhere. Be very, very handy for you. One thing to remember too about feed lines, if it's not terminated into the exact impedance of the feed line, it will transform, okay? So, if you're not familiar with the Smith charts, I don't know if you can see my laser here. If you're looking at it, there's one straight line going across the center from left to right. The only straight line there, that's resistance. All the other curved lines are actually a circle. They're part of a circle. The whole circle isn't there, but only part of the circle. That's reactance. Above the line is inductance. Below the line is capacitance. Around the edges, you'll see, like coming around here and going around here, you'll see 2 of them towards generator or towards load. Generator is your transmitter. So if you're doing some wavelength calculations from your antenna towards your transmitter, then it's towards the generator. If you're going to do some calculations from the transmitter toward the antenna, it's toward the load. Your antenna is the load. What I did is I did a couple of calculations ahead of time, since we only have 10 minutes, just to show you about how we're going to do it. So let's say we got our feed line there in the shack, and we take a measurement of it. 100 resistance and capacitive 100 ohms. So we're going to plot that. Now how we plot that, say we're going to use a 50 ohm feed line. Okay, so both of those are 100. We're going to divide that by 50, and we end up with 2 for each of it. So what we're going to do is we're going to plot that 2 resistance and 2 capacitive reactance. 2 resistance is right here. Okay, on the straight line. Remember, the straight line was resistance. They got 2 reactance, capacitive here. Where they cross is right there. Okay? Did everybody see that? Everybody following with me there on your paper?
Just point at it. Right.
Just point it, Greg says.
No, with your hand.
Yeah, it's a little tough to do with the shining in my eyes, but right there. Okay. Now, if you're doing this on your desk, what you do is you would take a ruler from the center point here, the center point is 1, and to your spot here where you marked your spot, and you would draw a line all the way through. Okay? Now you physically have a distance from the center point 1 to our plot right here, which is 2 and 2, right here. Physically, that resistance, you actually measure it, okay? And you measure with a ruler, or you can mark it on a piece of paper, this distance, say it's this far. You take one end on the center, bring the other one on over here, that'll tell you what your SWR is. This case, 4. So the SWR of that antenna at that feed line in the shack is 4. Smith chart does this for you. Everybody with me? Anybody questions so far with that? Okay. So we have our line that goes all the way through, and this is even hard for me to read up here.
Imagine what it is for me.
No. Yeah, you know, I was going to get on the net and suggest everybody bring their reading glasses and bring their magnifying glasses. Okay. But as you go through the outside of the Smith chart, you'll see on wavelength it'll say 0.21 out here. If you follow that straight line from the center, straight through, it'll go right through 0.21. You were with me so far? Now, let's just say we have our feed line is a wavelength of 0.2 wavelengths, okay? So, if we bring from 0.2 one right here and stop, we get 0.04 wavelengths. So if we go toward the load, 0.04 wavelengths, we've now removed all the reactance. Now we're left only with resistance, and then we were at 2. We normalized that because we had a 50 ohm feed line, and if you remember, our resistance was 100, so 2. Now if you do the SWR thing, if you replotted that again, now your SWR is 2. By changing your feed line, only 0.04 wavelengths. And if I misstate anything or somebody, you can go ahead and catch me. If you want to continue on, our feed line length, 0.2 wavelengths, if we want to follow it all the way around, we would come over here to 0.41. Remember, we're going around this way, which is toward the load. Right over here, it'll say toward the load. Now we would draw another line again from the center point, straight through that plot. And then what that will tell you is the impedance at the antenna, without going up to the antenna to measure it. And it's that same distance. So we would plot that here, measure that same distance. Okay? That's our impedance at the antenna. Now, one thing kind of interesting about this too, all the way around the Smith chart, one complete turn is a half a wavelength. And remember, we're only talking about one frequency here. That's a half a wavelength. So say at first we plotted our SWR here, or impedance here. If we add a half wavelength of feed line, we go all the way around one time and we end up in the same place we were before. It repeats. Doesn't matter what feed line you have. So if you've got a 50 ohm antenna, 50 ohm resistance and no reactance at the antenna, a half wavelength of feed line, you have the same thing, no matter if it's 50 ohm coax or 450 ohm ladder line or 300 ohm ladder line or whatever the heck it is. You end up with the same thing. The only other thing to remember here is we got to figure in velocity factor on your distances. So that's why I always say measure your feed line before you put it up. Then figure out the velocity factor of it. And most of the RG8s, maybe somebody can correct me, but 0.68. Is that about right, guys? And most ladder lines is like 0.92, 0.95. Is that about right, you guys think? So you always have to figure that in. So if you got 100 feet of feed line, then you got to multiply that times your velocity factor. And if you're not sure what that is, you can look it up, contact the manufacturer or whatever. Anyway, that's how you plot your impedances on the Smith chart. So do we have a few minutes for any questions?
Yeah, actually a couple do. Yeah.
Okay. Well, it's hard to make it clear up here. It really is. What I really wish I had was an overhead projector and I could draw stuff, but not quite that sophisticated. Okay, yeah, Brian?
Before you start calculating everything, do you apply your velocity factor to your feed line length?
No.
Before you calculate or after?
No. You don't have to. You just figure it all in at the end. and you're only going in wavelengths. So, you know, a half wavelength with the velocity factor is whatever feed you have. And everybody remember too, this is only at one frequency here. Does anybody else have anything to add that maybe I missed here that I should have mentioned here? Okay, one thing that I do like I don't know why that thing goes to sleep so quick. I set it to, and it doesn't listen to me. I hate Windows 10.
I know the inner guy.
The big hammer, right?
Yeah.
Yeah. Oh, who's that? But anyways, you can see, like the first calculation I was showing you, we got rid of the reactance and we cut our SWR in half. It was 4 with reactance, and we got rid of all the reactance. So if your tuner has trouble tuning something, this is the reason why all of a sudden you can change the length of the feed line and the tuner all of a sudden now has no problem with it. Especially an automatic tuner or an automatic internal tuner. You might be tuning around the radio, hit the automatic tune button, it tries to find a spot and errors out and go, what the heck's going on? And then you change the length of the feed line, all of a sudden it's happy. So that's how you can actually do some tuning to your favorite frequency and get your tuner to be happy. And it keeps the voltages less too inside, less chance of arcing and all that. Yeah, Bob?
2 quick questions. When if you're trimming feed line, like say ladder line, to get it to tune, how many feet do you normally chop off? Do you chop off feet, chop off inches?
Yeah, okay.
General,
If everybody heard how much do you add to or remove of your feed line, it's in wavelengths. So if you're on 160 meters, it's going to be in feet. If you're going to be in 2 meters doing the exact same calculations, it's going to be in inches. So, and that calculation I did was 0.04 wavelengths, regardless of the frequency. 0.04 wavelengths at 160 meters is going to be a few feet or whatever, and it's going to be a few centimeters at 2 meters. So that's the beauty of this. We just pick a frequency and we take some measurements and we figure it all out in wavelengths. Was there something else?
Yeah. Another ladder line question. Is there an advantage of 300 ohm over 450 in general dipole design?
Not that I can think of. I don't know.
Okay.
Okay, so you had a question there?
Well, comment is that you want it as close to your antenna impedance, so you have less transition or multiplication, quarter wave line.
You mean make adjustments closer to the antenna instead of, is that what you're saying?
No, impedance. You want the impedance closer to the antenna impedance. Otherwise, you're going to have transitioning like the quarter wave transformer effect.
Yeah, if you can do that, absolutely, yeah. So this other plot that I made after we came around and figured out the impedance at the antenna, okay, if you do the math, you come out here, you end up on the Smith chart, too bad it's gone, but you can see 0.35 resistance, and now we've come to the top side as we came around to the top. We came around now to the inductive side. So it's 0.6 inductive, 0.35 resistance on the Smith chart. Now you take that and you multiply it. Now that we're all done, we normalized it to the chart. Now we're going to multiply it back and unnormalize it back to our feed line, which we were assuming here the whole time, which was a 50 ohm feed line. And our end result is rounded off figures. 17 resistance, 30 inductive reactance. That's what that antenna is at that spot. Anybody got anything else? Is everybody following me with it? I know it's kind of weird, and years ago I was pretty good with it, then I didn't do it for a long time, and then all of a sudden I got rusty and I had to start reading on it again. But, I'm definitely not an expert on it, but what I wanted to show you guys here in 2 different Tech 10s was just the idea of how it works, and you don't have to remember it, but if you know how it works and then you're working on a project, you remember how it works and you can go look it up and then you can apply it. It's kind of like all our electronics formulas. There's no way we can remember all these electronics formulas, no way. But if you know how to find the formula you need because you're working on a project, then you can do it. Then you can go look it up and research it. So, next month what we'll do is I'll show you how to get the resistance back to 50 ohms and the reactance to 0 by putting a stub in the line. Okay, and we can use the chart for that. Yeah, Earl?
Yeah, there are of course many things you can do with the Smith chart. What do you use for reference to look up what you want to do? Do you have a place on the internet that you go to look up how to use the chart? Or
That's a good spot. I think the ARRL books have stuff on it, or they used to. The older ARRL books do. Yeah, that's what I would do. But nowadays with the internet,
now, do you have a particular site that you like to use?
not particularly. No, not particularly. So this also, when you do these calculations, it assumes lossless. It's a lossless line. Well, you know, in all reality, that's not the case. So when you do these calculations and you work on your antenna, your feed line, whatever, you're going to come really close, but you still might have to do a little trimming or something. But I mean, this is exactly what I've done with my antenna. I have a 160 meter antenna, and I've got some switches in there. I can switch in different lengths of ladder line, and I can have a perfect match from about 7160 on 40 meters up to about 7260 on 40 meters. I don't need a tuner there anywhere. Just work my switches and switch in the proper lengths of ladder line for that frequency, and I've got it. There's a guy that does have a website. He's back in Texas. He has a real elaborate switching mechanism where he switches ladder line in and out. Doesn't need a tuner. All in and out. Real elaborate. Someday I may set mine up like that too. But your transmitter's happy because it'll see 50 ohms and virtually no reactance. Any other?
There's an app for your phone that you can get for Smith chart plotting, and there's actually a good program for these.
Okay, yeah, Rich said there's an app for your phone that'll do it, and free programs. You know, I downloaded a free program to play with it one time. I couldn't figure out how to make the thing work. The piece of paper, the ruler, and the pencil, I didn't seem to have a problem with. But then you find out, okay, after you use the free program for a while, oh, if you really want it right, then you can buy the rest of it. Oh, okay. Now I figured out, you left something out. You were teasing me, you left something out. Okay, do we have another minute?
Nope, we're out.
We're out of time.
We're out of time.
One more quick question if somebody's got one. Okay, that's it. Thanks, I hope you guys